It is not acceptable to use a thermostat rated to 22 amps to switch a 22 amp load on a 30 amp circuit breaker. The thermostat is the weakest link in the circuit, so it must be rated for the full load current. If the load current exceeds the thermostat's rating, the thermostat contacts could overheat and fail, creating a safety hazard. The National Electrical Code, or NEC, requires that the thermostat rating be at least equal to the load current. In this case, the load current is 22 amps, so the thermostat must be rated for at least 22 amps. The contactor is a backup protection device that is designed to open the circuit in the event of a fault. The contactor's rating should be equal to or greater than the circuit breaker rating. In this case, the circuit breaker is rated for 30 amps, so the contactor should be rated for at least 30 amps. Using a thermostat rated to 22 amps to switch a 22 amp load on a 30 amp circuit breaker could create a safety hazard and is not in compliance with the NEC. Both the thermostat and the contactor must be rated for the full load current and the circuit breaker rating, respectively. When dealing with electrical systems, it's crucial to understand the relationship between different components and their ratings. One of the most important concepts is ensuring that all devices in a circuit are properly sized to handle the expected current. In this specific scenario, a thermostat is being used to control a 22 amp load on a circuit protected by a 30 amp circuit breaker. The question arises whether a thermostat rated for 22 amps is suitable for this application. The answer is no, it is not acceptable. The thermostat acts as the primary control device in the circuit, directly switching the 22 amp load on and off. As such, it is the weakest link in the system and must be able to safely handle the full load current. If the load current exceeds the thermostat's rating, the thermostat's internal contacts can overheat. This overheating can lead to a variety of problems, including contact failure, arcing, and even fire. The National Electrical Code, a widely adopted standard for safe electrical installations, provides clear guidelines on this matter. The NEC mandates that the thermostat's rating must be at least equal to the load current it is intended to control. In this case, since the load current is 22 amps, the thermostat must be rated for at least 22 amps. However, simply meeting the minimum rating isn't always sufficient. It is generally recommended to use a thermostat with a slightly higher rating than the actual load current to provide a safety margin and account for potential overloads or surges. While the thermostat directly controls the load, the circuit breaker provides overcurrent protection for the entire circuit. In this scenario, a 30 amp circuit breaker is installed. The circuit breaker's purpose is to trip and interrupt the circuit if the current exceeds its rated value, thereby preventing damage to the wiring and connected equipment. The contactor is another important component to consider. A contactor is an electrically controlled switch used to switch a power circuit. In this application, the contactor serves as a backup protection device. It is designed to open the circuit in the event of a fault or overload condition. The contactor's rating should be equal to or greater than the circuit breaker rating. In this case, since the circuit breaker is rated for 30 amps, the contactor should also be rated for at least 30 amps. This ensures that the contactor can safely interrupt the circuit under fault conditions. Using a thermostat rated for 22 amps to control a 22 amp load on a 30 amp circuit breaker creates a safety hazard and violates the NEC. To ensure a safe and compliant installation, both the thermostat and the contactor must be rated for the full load current and the circuit breaker rating, respectively. Firstly, select a thermostat with a rating equal to or greater than the load current, with a safety margin for potential overloads. Secondly, choose a contactor with a rating equal to or greater than the circuit breaker rating. Thirdly, ensure that all wiring and connections are properly sized and installed according to the NEC. It's important to remember that electrical work can be dangerous and should only be performed by qualified and licensed electricians. Ignoring safety guidelines and code requirements can have serious consequences, including electrical shocks, fires, and property damage. If you have any questions or concerns about electrical installations, always consult with a qualified electrician. Let's delve deeper into the technical aspects of thermostat and circuit breaker compatibility. The thermostat, as previously mentioned, acts as the primary control device for the load. It is responsible for switching the current on and off based on temperature or other control parameters. The thermostat's contacts are the critical components that carry the current. These contacts are typically made of a conductive material, such as copper or silver alloy, and are designed to withstand the heat generated by the current flow. However, if the current exceeds the thermostat's rating, the contacts can overheat, leading to degradation and eventual failure. Overheating can also cause the insulation surrounding the contacts to break down, creating a short circuit and potentially igniting a fire. Circuit breakers are designed to protect electrical circuits from overcurrents, which can be caused by short circuits, ground faults, or overloads. When an overcurrent occurs, the circuit breaker trips, interrupting the flow of electricity and preventing damage to the wiring and connected equipment. Circuit breakers are rated in amps, which indicates the maximum current they can safely carry without tripping. The circuit breaker's rating should be selected based on the size of the conductors in the circuit and the expected load current. It is important to choose a circuit breaker that is appropriately sized for the application. If the circuit breaker is too small, it will trip frequently, interrupting power to the load. If the circuit breaker is too large, it may not trip in the event of an overcurrent, potentially allowing damage to occur. The National Electrical Code provides detailed guidelines for selecting the appropriate circuit breaker size for various applications. The NEC tables, such as Table 310.15b16, provide ampacity ratings for different types of conductors based on their size and insulation type. These tables can be used to determine the maximum current that a conductor can safely carry. When selecting a circuit breaker, it is important to consider the ampacity of the conductors in the circuit. The circuit breaker should be sized no larger than the ampacity of the smallest conductor in the circuit. This ensures that the conductors are protected from overcurrents. In addition to the circuit breaker, a contactor is often used in conjunction with a thermostat to control larger loads. A contactor is an electrically controlled switch that is used to switch a power circuit. Contactors are typically used in applications where the load current is too high for a thermostat to directly control. The contactor is controlled by the thermostat, which sends a signal to the contactor to open or close the circuit. The contactor's contacts are designed to handle much higher currents than the thermostat's contacts. Contactors are rated in amps, which indicates the maximum current they can safely carry. The contactor's rating should be equal to or greater than the circuit breaker rating. This ensures that the contactor can safely interrupt the circuit under fault conditions. When selecting a contactor, it is important to consider the voltage and current requirements of the load. The contactor must be rated for the voltage and current of the load. It is also important to consider the type of load being controlled. Some loads, such as motors, require special contactors that are designed to handle the inrush current that occurs when the motor starts. In summary, using a thermostat rated for 22 amps to control a 22 amp load on a 30 amp circuit breaker is not acceptable. The thermostat must be rated for at least 22 amps, and it is recommended to use a thermostat with a slightly higher rating to provide a safety margin. The contactor should be rated for at least 30 amps, which is the rating of the circuit breaker. All wiring and connections must be properly sized and installed according to the NEC. Understanding the relationship between different electrical components and their ratings is crucial for ensuring a safe and reliable electrical system. Always consult with a qualified electrician if you have any questions or concerns about electrical installations. Let's examine some additional aspects related to this scenario. We'll discuss conductor sizing, overcurrent protection, and the importance of proper installation practices. Conductor sizing is a critical aspect of electrical installations. The conductors, or wires, that carry the current must be sized appropriately to handle the expected load current. If the conductors are too small, they can overheat, leading to insulation breakdown and potentially causing a fire. The National Electrical Code provides detailed guidelines for conductor sizing. The NEC tables, such as Table 310.15b16, provide ampacity ratings for different types of conductors based on their size and insulation type. The ampacity of a conductor is the maximum current that it can safely carry without overheating. When selecting conductors, it is important to consider the following factors. Firstly, the load current. The conductors must be sized to carry the expected load current. Secondly, the ambient temperature. The ampacity of a conductor decreases as the ambient temperature increases. Thirdly, the number of conductors in a raceway or cable. When multiple conductors are installed in a raceway or cable, their ampacity must be derivated to account for the increased heat generated. Fourthly, the termination temperature rating of the equipment. The equipment to which the conductors are connected must be rated for the temperature that the conductors will reach. Overcurrent protection is another essential aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overcurrents, which can be caused by short circuits, ground faults, or overloads. When an overcurrent occurs, the overcurrent protection device trips, interrupting the flow of electricity and preventing damage to the wiring and connected equipment. Circuit breakers are typically used in residential and commercial electrical systems. Fuses are typically used in industrial electrical systems. Circuit breakers and fuses are rated in amps, which indicates the maximum current they can safely carry without tripping. The rating of the overcurrent protection device should be selected based on the size of the conductors in the circuit and the expected load current. It is important to choose an overcurrent protection device that is appropriately sized for the application. If the overcurrent protection device is too small, it will trip frequently, interrupting power to the load. If the overcurrent protection device is too large, it may not trip in the event of an overcurrent, potentially allowing damage to occur. Proper installation practices are also crucial for ensuring a safe and reliable electrical system. Electrical work should only be performed by qualified and licensed electricians. Improperly installed electrical wiring can create a safety hazard and increase the risk of electrical shocks, fires, and property damage. When installing electrical wiring, it is important to follow all applicable codes and standards. The National Electrical Code provides detailed guidelines for electrical installations. Some important installation practices include, firstly, using the correct wiring methods. The wiring method used should be appropriate for the application. Secondly, properly grounding the electrical system. Grounding provides a path for fault currents to flow back to the source, which helps to protect people from electrical shocks. Thirdly, making sure all connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to fires. Fourthly, protecting the wiring from physical damage. Wiring should be protected from physical damage by using conduit or other protective measures. In conclusion, the scenario of using a 22 amp thermostat on a 22 amp load with a 30 amp circuit breaker highlights the importance of understanding electrical codes, component ratings, and proper installation practices. A thermostat rated for less than the circuit breaker is a dangerous and code-violating practice.